So, children, listen carefully. Today's class, we are going to start the topic with effect of pressure on the melting point. Effect of pressure on the melting point. What do you mean by melting? What do you mean by melting? Change of phase from solid to liquid state by absorbing heat without any change in temperature. Am I right? Now, children, there are certain substances will contract during melting process. For example, you can take ice. Ice is a solid substance. Due to melting process, ice is contracting. Because of that contraction, it will become liquid. Am I right? So you can understand that when the melting point increases or the melting increases, the contraction of certain substances will increase. Right? Now, this can be decreased by increasing pressure. This can be decreased by increasing pressure. Children, please understand, there are certain substances during melting process, they will contract. Am I right? This process can be decreased by increase in pressure. Similarly, there are certain substances which will expand on melting. For example, you can take lead. Lead and all, during melting process, it will expand. Understood? This also increased by increasing the pressure. Fine. So there are substances which will contract during melting, ice and all. It can be decreased by increasing the pressure. There are certain substances which will expand on melting process. For example, lead. That also increase by increasing the pressure. Is it okay? Fine. Listen. Effect of impurities on melting point. What happens when you add some impurity, the substance? What happens to the melting point of that particular substance? What happens? Children, the melting point of a substance can be decreased by adding some impurities. For example, what is the melting point of ice? 0 degrees Celsius. That 0 degrees Celsius melting point of an ice can be decreased into minus 220 degrees Celsius by adding the impurity salt. Understood? So children, what is the effect of impurity on melting point? The melting point of a substance can be decreased by adding impurities. For example, you can take ice. Generally, the melting point of ice is 0 degrees Celsius. By adding salt, its melting point will decrease to minus 22 degrees Celsius. Understood? Children, listen carefully. Now we are going to talk about another process, vaporization and condensation. Vaporization is also known as boiling. Children, you just consider the state liquid and gas. So by absorbing heat energy, now liquid is going to convert into gas without any change in temperature. So the change from liquid phase to gas phase, the change from liquid to gas phase on absorption of heat energy at a constant temperature, we call it as vaporization or boiling. So what do you mean by boiling point? The temperature at which the vaporization occurs is called boiling point of liquid. Fine. All the terms you already studied. 8th standard, 9th standard only. Now, condensation or liquefaction. What do you mean by condensation? Children, what you studied in vaporization, opposite is going to happen. Vapor will be converted into liquid. Vapor will be converted into liquid by releasing heat energy or by liberating heat energy at a constant temperature. We call it as condensation or liquefaction. So what do you mean by condensation point of water? The particular temperature at which condensation occurs, we call it as condensation point of water. When they ask question opposite, you should write, okay. Condensation point, when they ask, you should write boiling point. Then they will give marks. Understood? I know you guys will make that mistake only. So children, this terms you guys studied from 8th standard, 9th standard also you guys studied. Now also you guys are getting confusion. The reason is nothing but you guys are reading and studying. One time at least write and study each term. Then only you can remember. In MCQ, they will ask this type of question. That's why This is very important. Understood? Now, next one. Now, for a pure substance, already in the other terms of the melting point, we discussed the same. So for pure substance, what happened? Both the point, boiling point and condensation point will be identical. Now I'm just showing one example. Children, I told you both the cases, the temperature will be same, right? Condensation and boiling, both the cases, the temperature will be same. So when 100 degree of water, 100 degrees Celsius of water absorb heat energy, it will be converted into 100 degrees Celsius of steam. That means there is no change in temperature, but the phase has changed, right? So that process we call it as boiling. Now you just consider 100 degrees Celsius of steam, vapor. By liberating heat energy, it will become 100 degrees Celsius of water. There is no difference in temperature. That process we call it as condensation. Example is okay for everyone. Children, now we are going to talk about heating curve for water. Children, here you can see the heating curve starts at 20 degrees Celsius, right? You can see the point A is at 20 degrees Celsius. Why it is at 20 degrees Celsius? Why it is not starting from 0? Children, room temperature will be the right. There will be some room temperature. So here the room temperature we are considering it as 20 degrees Celsius. So from this point we are starting the liquid phase. So the liquid phase starts from point A, which is at 20 degrees Celsius. When you guys are drawing heating curve for water, you should remember you should consider the room temperature. So it should start from some other point, not at 0. Fine. Now, from there onwards, that means point A onwards, this particular liquid will absorb heat energy. Because of that reason, the temperature rises continuously in the part AB. Fine. When that temperature reaches 100 degrees Celsius, it will change its phase, right? The liquid phase, it will change it to vapor state. So at the point B, we call it as boiling point of water. From the point B, there is no much rise in temperature, right? It became vapor. So at vapor, it is at 100 degrees Celsius. Constantly they are moving. That is nothing but BC. Any doubts? So why you guys started at 20 degrees Celsius? Because room temperature you should consider. Hence you start with 20 degrees Celsius. Then it will the liquid will absorb heat energy in order to convert one phase to another phase. So at point B, the temperature becomes 100 degrees Celsius. Then boiling will start. That means vaporization. Sorry, boiling will start. Understood? No doubts, right? So this is very important. Please mark it as very important for your exam point of view. Yes. So children, now please listen. What are the changes in volume during boiling? Children, please understand, comparing with other case, here only one change. When boiling happens, all the liquids will undergo expansion. During boiling process, all the liquids will undergo expansion. Now, what is the effect of pressure on boiling point? Children, boiling point of a liquid increases means, sorry, if the pressure increases means the boiling point of liquid also will increase. If the pressure decrease, the boiling point of liquid also will decrease. Fine. So please understand, on boiling, all the liquids will undergo expansion. Second one, what is the effect of pressure on boiling point? Pressure increases, boiling point increases. Pressure decreases, boiling point decreases, directly proportional in this case. Fine. Now next one. Now this is one general. This is one general question. You can expect this question for your exam. General, give reason type. Water boils at 120 degrees Celsius in pressure cooker. Why? Children, boiling point is nothing but 100 degrees Celsius, right? Then why pressure cooker? It takes 120 degrees Celsius. My pressure cooker I bought for more money. That is the reason. My pressure cooker is costly, so it should boil at 120 degrees Celsius. Is there anything like that? No. Reason is nothing but in a pressure cooker, steam is not allowed to escape out. Inside the pressure cooker, the steam is not allowed to escape out. That's why when you're opening that pressure cooker, that much pressure it is giving. You see, no? That much pressure is there. So steam is not allowed to go out inside a pressure cooker. So what happened? Because of this reason, the vapor pressure on water inside the pressure cooker becomes 1.75 times that of atmospheric pressure. That means above atmospheric pressure, the vapor pressure will increase inside the pressure cooker. How it is possible? Inside the pressure cooker, steam is not allowed to go out. Because of that reason, the vapor pressure will increase more than the atmospheric pressure. So what happens? When pressure increases, boiling point also increases. We studied now, right? So because of this reason, when the pressure increases, the boiling point of water also increases. Hence, here the boiling point increased to 120 degrees Celsius. Fine. Any doubts? Okay. Why pressure cooker works at 120 degrees Celsius? Boiling point of pressure cooker is 120 degrees Celsius. Steam is not allowed to go out. That is the first reason. Second reason is nothing but because of that reason. That means steam is not allowed to go out. Because of that reason, the vapor pressure will increase 1.75 times more than atmospheric pressure. When atmospheric pressure increases, the boiling point of water also, liquid also will increase. We studied that. Hence, the 100 degrees Celsius boiling point will increase to 120 degrees Celsius in a pressure cooker. Fine. Now, children, the same condition, if I consider in a high altitude place, what happens? Boiling point will reduce, right? Why? At high altitude, the atmospheric pressure is nothing but very less. When the atmospheric pressure is decreased, when pressure reduces, what happens? Boiling point decreases. Already, sir explained this concept. So pressure decreases, boiling point decreases. That concept you know. So at high altitude, the water will boil at temperature below 100 degrees Celsius. So below 100 degrees Celsius means it will take more time to give the heat energy for cooking. This is the reason. Children, these two conditions you can explain with one statement. That is nothing but when pressure increases, boiling point increases. That is the first case in the pressure cooker. Second case, at high altitude, when pressure decreases, boiling point decreases. That's happened in the case of high altitude. Any doubts? Fine. Now, we are going to talk about the effect of impurities on boiling point. The effect of impurities on boiling point. The other case we discussed, what we discussed, children? So effect of impurities on melting point. If you add impurity, the melting point will decrease. Because of that reason, ice at 0 degree, now it converted to minus 22 degrees Celsius. You remember that concept. So what happened during melting? If you consider melting process, if you add some impurity, what happened? The melting point will decrease. In this case, it is opposite. If you add impurity, then boiling point will increase. If you add impurity or into a liquid, the boiling point will increase. For example, children, you guys know water. Boiling point is nothing but 100 degrees Celsius. You just add some salt into that water. Then that boiling point of that water, salt mixed water will be above 100 degrees Celsius. That is an example you can elaborate. Understood? Any doubts? So this much only about calorimetry. Okay. So with this, I'm completing calorimetry chapter. Please remember heating curve and all is very important. Okay. So thank you, children.